Good morning, everyone, or good afternoon if you are in Latin America. My name is Francisco Munoz Alvarez. I'm the president of New Zealand Oracle User Group, a Latin American Oracle User Council or user community. It's an honor to me introduce today Mr. Daniel Morgan. A lot of people know him from the OTN forums or from the Morgan's his library. It's a fantastic resource to everyone around the world using the internet. He's a good friend and a fellow ACE director. And now I'm going to leave Daniel to start the presentation. Go ahead, Daniel, and welcome to LLC and NZOG.
Thank you very much, Francisco. I appreciate the opportunity to present again to you and your groups, both in New Zealand and in Latin America. And I hope this presentation goes well for everyone. It's hard for me to know what you're seeing, but at least you're not seeing my face anymore. The presentation today is on how to read and interpret an explain plan. And one of the reasons why I like to cover this topic is that I find that a lot of people look at explain plans but don't necessarily understand what they're looking at, and also cannot tell when an explain plan is showing them misinformation or showing them information that is not valid. So today's presentation will be 1 hour and is designed to take you through how to properly generate an explain plan, how to read the explain plan, and how to interpret the explain plan, plus a few comments about other ways of doing explain plans and why they are unsatisfactory. So I think everyone pretty much knows me. I'm not going to spend any time on introducing myself other than to say that I have given a copy of these slides in PDF format to Francisco, and I'm sure he will post them on appropriate websites, plus they will be posted on my website as well at morganslibrary.org. So I will move on from that. We're going to really have 4 sections today. Explain plan, explain. I'll talk a little bit about what an explain plan is and why they are of value to us. How to create them, how to read and interpret them, and finally, if time permits, some final thoughts. And at the very end of the presentation, I'm not going to go through it most likely. I have put a quite complex explain plan into the presentation slide so that if you download it, you should be able to have lots of fun testing your knowledge of how to read an explain plan. So the first thing we'll do is talk about what an explain plan is and what the origins of these are. Explain plans were certainly something that I bumped into back in the early 1990s when I first got into Oracle, and something that has changed quite dramatically since I first got in, but we'll get to that in just a moment. An explain plan is Oracle giving us a way of saying to the optimizer, here's a DML statement, insert, update, delete, merge, or select statement, and essentially saying to the optimizer, what is it that you think you're going to do with this statement? Please tell me. It's important to understand that what the explain plan tells you is not necessarily what Oracle will actually do, and we'll talk about that a little bit more, and I'll show you how you can find out what the real plan is, because sometimes we do find, it's not often, but we do find that the real plan is not the same as what explain plan told us. So when we do an explain plan, what we're saying is to the optimizer, tell me what you think you're going to do, but it doesn't actually execute the statement. It makes assumptions based on statistics that have been collected, but it doesn't actually run anything. So an explain plan on a query that takes 5 hours to run will take the exact same amount of time as an explain plan on a statement that takes 5 milliseconds to run. And we get the information from the optimizer by looking at something called plan table. Now, back in older versions of Oracle, a plan table was an actual table. These days, it is just a synonym that points to a global temporary table named plan $sign. So again, sort of going back to the old version 7, version 8.0 days, we had the and the role-based optimizer pretty much stepped its way through version 7 type objects with a group of 14 rules and said, if what you're doing doesn't satisfy one of these 14 rules, then the answer to every question becomes full table scan. When we get into the cost-based optimizer, which has been the standard now for quite a few generations of Oracle, everything that we do is based on a statistic. Be able to look and see that the table has not been analyzed yet. Oracle's optimizer has no idea what's actually in the table. You can use the last analyzed column to determine how long it's been since it's been analyzed. You can then collect statistics and then look again, and you'll see that the analysis has been done and the information has been collected for the optimizer. The other thing that I want to point out in preparation to talking about explain plans is that a lot of times databases are upgraded or migrated. They are not fresh installs. And I have been seeing lately as people have been moving from 10G to 11G that we are getting situations where the values in their init.or or SP file have not been upgraded to match the version of the database they have. And there is built into DBMS utility something that will return to you both the version of your database, but also your compatible parameter, which is essentially saying which version of the optimizer am I using. If these two values are not in agreement, and in agreement with the higher value, you may have 11.107, but your optimizer would still be, in this case, running as 10.204. And I've seen a lot of times where the production server had this kind of a mismatch, but somebody had installed a brand new dev or a brand new test server. So while they looked like on the surface they were the same version, in fact they were not. So with these preparations out of the way, let's talk about getting past this tuning methodology of just guessing and getting into a methodology using explain plan where we actually learn and know something about what it is that Oracle is doing with our statements. So we start off by looking at a pretty simple select statement. In this case, I have one that says, essentially, tell me which server IDs are in two tables. So I could say, give me all the server IDs out of the servers table, give me the server IDs out of the servers installed table, do an intersection, tell me which ones you find in both tables. And if I wanted to do an explain plan, I would just take my SQL statement, or any DML statement. It could be insert, update, delete, or merge. Type explain plan 4 above it, and submit that to Oracle. Let's go ahead and do that with this statement right now. I am going to just take and copy this out of here, and I'm probably going to regret having done that, because things don't always copy well out of PowerPoints. PowerPoints just don't seem to handle this one little bit of the puzzle particularly well. So here's our SQL statement, and it returns 11 rows. And if I want to make it an explain plan, I would just say explain plan 4 and run it again. And Oracle says it has been explained. And it's that simple to create an explain plan in Oracle, and that has not changed since at least version 6 of the database. I don't go back older than that, so I don't know. What we then have to do after we have the plan is to extract it from the plan table or plan $sign where Oracle is storing the information. When I first got into Oracle, one of the most treasured possessions I had was this query that you see here with select LPAT, which I carried around with me and used for years and years because it was complex enough. I sure was not about to try to type that in by hand or figure out the logic and rewrite it. This is now strictly the material from which dinosaurs make decisions. And I haven't seen anything like this in quite some number of years. What we should be doing these days is using a built-in package called DBMS Xplan. DBMS Xplan first showed up in version 9 of Oracle. And there are a lot of reasons why any explain plan really must be done with DBMS Xplan. And I know there are third-party products out there that do explain plans, one of which is Toad. And I will, in a few minutes, show you why I wouldn't trust an explain plan produced by Toad. And I've seen other products, not to pick on Toad, that do a similarly inadequate job of producing explain plans. But having explained the statement, the only thing that's required is this select star from table, using the table operator, and then calling the pipeline table function display. So let's go ahead and do that. So we've just got done explaining the statement over here, and I'll ask for the report, and Oracle gives me the report indicating all of the actions that it believes it will take if the statement were in fact actually run. And you'll notice here that it thinks it's going to return 141 rows. We might be inclined to disagree with that result. And as I said, it's often the case that explain plan doesn't give you accurate information, and it's one of the things that you have to learn how to read these so that you can appreciate when you're getting accurate information and when you are not. I know a lot of people find it uncomfortable because of lack of familiarity with typing this particular statement or just can't remember it. And one of the things that I've recommended to my students over the years is just to put it into a view. So if you do a create or replace view, give it any name you want as, and just throw that statement in, then a select star from Xplan, or whatever the name of your view is, will in fact produce the explain plan for your current statement. So creating that view makes it very simple. You don't have to remember any syntax at all. The point at which we really want to spend the majority of our time today is on how to read and interpret explain plans. And it is both remarkably simple and it is counterintuitive. So let's take a look at some SQL statements. I have a group of about 14 or so statements that I wrote back about the Oracle 815 days as I was teaching Oracle at the University of Washington. And these are 4 of the statements, and I have some others coming up later. All of these statements produce the exact same result set. And the challenge that I gave to my students was, look at these statements, and just by eyeballing them, tell me which one of these statements is the best statement. Which one do you want to put into your production code? So here we have 4 statements that select the server ID. They take it from the server's tables and the server's installed table in all cases. And one of them uses an intersection, one uses in, one uses exists, and one is an inner join. And I have challenged people over the years to tell me which one is the best. And I find that most people don't know the answer to the question, except to say, well, you know, usually such and such is the fastest, but without understanding that it may change by version, it may change by patches, it may change by the nature of the data that's in those tables. Here are a couple of other ones that I've produced over the years. These are sort of the, can I make it a little more obscure or a little more difficult to retrieve those same 11 rows? And then I wrote a couple that I intentionally made the most obnoxious and difficult statements I could possibly write that would in fact still produce the 11 rows. The first one being a not with a minus, which is basically the double negative, meaning a positive, and the other one using a group by, and I'll let people sort out on their own why it is that this works, but does not work particularly efficiently. So let's go back to our original explain plan. We did a server ID, and let's go and review that particular one again. what I'm going to do is go to my website where I have this information on the explain plan. In the library, you can just look up the word explain. It'll take you right to the page where I've got all of the demos for this. And here's that old LPAD script, as well as over here you'll notice 4B, number 5, 6, and it just goes on down through number 13, 13 different ways of sort of producing that same result set. But let's take the one that has the existence in it and look at what that does. So I'm going to go ahead and explain that one. And let's go ahead and look at the plan that's generated from doing that. Different ways of approaching it, we get different plans. What we want to look at here is the information that is produced and the accuracy of what is produced. This is Oracle's internal explain plan using the explain package. And you'll notice that you get certain columns of information. Here, Oracle did, in fact, with this plan, produce the right number of rows. The last one I did, it thought there were 141. Obviously, it was not getting it correctly. Here, it doesn't, in fact, say, oh, yes, I do know this will return 11 rows. I can probably trust this a lot more than I could that last one I showed you. But what's critical is to look at what happens when you use Toad or other products, because there's a lot of misinformation and there is a lot of missing information that's absolutely critical. So I ran two queries, the first one using the latest version of Toad that I had available to me, and the second one in Devious X-Plan. So this is the plan that came back from Toad. It's nice and colorful, but it's got some pretty serious problems. So let's go through what some of those problems are. They've got a full table access, and they're showing the parallel threads, and they got the IDs correct, and the operations and the names, and they got the costs and the in-out on the parallel query correct. But let's talk about what was missing using Toad. The first thing is they got the cardinality in the rows wrong. This returns 107 rows. For some reason, they think it's 409. In addition to that, they got the number of bytes wrong. And in fact, I verified these numbers, and Oracle's numbers in this case are in fact accurate. They also didn't produce any information about what percentage of the cost was CPU. So if you look back to this Toad plan, CPU just does not exist. You have no way of knowing what's happening. The time is not reported. And finally, and really importantly, it turns out that what Oracle did was dynamic sampling. What it said was that the statistics were not current, or didn't trust the statistics, and it went in and dynamically sampled that table, looking at what was in a few blocks, and then came back to make its decisions. This was also not recorded by Toad. Here's another one that was done using both Toad and the Oracle Devious X plan. And this one demonstrates one of the most egregious problems that you'll find if you don't use the proper explain plan methodology. In this case, what I did was I said, pull the source code out of source $, and by the way, throw an order by at it. And according to Toad, 577 was the cost here. By the time we got done with the order by, it was 3,400 and 98,000 rows. And these things were actually absolutely accurate. But here's the problem. 25 megabytes was swapped to the temp table space. Code doesn't know this. It is not able to be dynamic. Devious X plan will dynamically add columns to the explain plan output if they are appropriate to what you're doing. If you're doing bitmap indexes, if you're doing partition pruning, if you're doing parallel query, or in this case, swapping to the temp table space, Oracle says this is information that's important to you. You need to know you just spent a whole bunch of disk I/O swapping information out. It didn't record the CPU, and again, didn't record the timing on this operation. So the reason why we use Devious X plan is, first of all, it is in fact the most accurate explain plan because is in line with the optimizer and what the optimizer is thinking and how it's prepared. It also gets upgraded every single time you patch your database. So if you have 11.106 and you apply an 11.107 patch, DBMS Plan may also be patched in order to take advantage of any changes that take place. If you have 11.201, later this year we're going to have the 11.202 patch, I would expect that one of the patches that will go in there that you won't necessarily see, but will be to adjust DBMS Plan. The next reason, it understands all of Oracle's data types and all of Oracle's object types. This is not true of other plan methodologies and other products. And probably the most important one to me is the fact that it's free, because I just don't see the value in spending money to get something from somebody that I already have. So I'm going to encourage everyone, go to the SQL Plus command line and do it this way. You'll be a lot happier with the results. So let's move on now, and let's look at how to read an explain plan. This is the explain plan report that was done using that exist query that I just did a moment ago. And here's the output again, showing that it did in fact do dynamic sampling. This is the line right here, number 3, that is if that's what it's most likely to have done first. The second instruction is if 2 lines are indented equally, the top line is normally executed first. So if we start off with this index fast full scan, we have 2 lines here that are at the same level. It is most likely that Oracle did this first. So it will do the index fast full scan, then go to the sort unique, then drop down. So let's walk our way through this one in just a second. The other thing that's critical is understanding the CPU percentage. You'll notice here that there is a percent CPU, and there's a lot of misunderstanding in terms of what that means. And I've heard people say, oh, that's 25% of the CPU on the machine, and or 25% of the cores. It is not. It's actually a factor that you apply against the cost. So if in this case, the disk I/O of reading that index was 3, 25% is 3, you've essentially just added 1 unit of CPU, therefore 25%. So let's walk through this one and see what happens. I've got this numbered down at the bottom, so you should be able to follow along both while we're doing it here and also once you get the slides. First thing Oracle's going to do, index fast full scan. The optimizer believes that that index fast full scan is going to read 999 rows out of that index, approximately 13K of information, probably stored in 3 8K blocks on my hard disk. The amount of CPU utilized is so low as to not count. The next thing will be to sort that index scan for unique values. It knows in this particular case the index is not a unique index, so it has to get rid of the duplicates. That does in fact require CPU, but it's such a small amount of CPU it doesn't even rise to the level of being written. The third thing that will happen is that Oracle is now going to do an index unique scan, and it's assuming here that it's only going to read 1 row. That is in fact incorrect. It actually ends up reading more rows than that. So it's a bit of an error, and it's one that you can sort out, but it's not particularly critical here. The main thing is that this index is a primary key index and is extremely efficient. So you essentially have a 0 cost from the standpoint of the optimizer in doing that. The rule when you have 2 things at the same level is that Oracle will sum these things to come out to the left. So 0 plus 3, well, that's not a 3. So let's talk about where that comes from. We sum these 2 at the same level, 0 plus 3, but now Oracle goes into a nested loop. The nested loop is pure CPU, and Oracle determines that the cost after that nested loop is 4, which consists of essentially the 3 8K blocks that were read, plus a rough equivalency in overhead of 1 block's read as CPU as it goes through the nested loop. So the total cost at this point is 4. 25% of that 4 is the CPU, so you've got 3 plus 1. And that's what you should end up with in terms of what is reported back to the client. Let's take a look at a slightly more complex explain plan. In this case, we have 2 index scans at the same level of indenting to the right. The rule is that Oracle will probably do the one above first. So with some degree of faith in the Oracle documentation being accurate, we're going to have to look at this as Oracle does an index full scan on the PK servers index. Now you'll remember back here, I said this one was not correct. Over here, it did in fact get this correct. There are in fact 141 entries there. So it reads all 141 entries, and it thinks those 141 entries are stored in one 8K block. It will then do the same thing down here with the non-unique index of servers installed and sort for unique values. Again, it's correct here, 999 rows stored in 3 blocks. And then you'll recall that we sum at the level of these outdents. So these two, the results of both these sorts are going to get summed and put into this minus. We've got a view created from that. And Oracle says at this point the cost is 6. And this is where, again, understanding how the CPU comes into this calculation helps you understand what's happening. Oracle believes that at this point it's going to have 141 rows, the result of the intersection of these 2 unique sorts. And when you sort uniquely, you will in fact get that. The cost here is 4 units of disk I/O, 4 plus 2, 2 units of CPU is 6, so 4 plus 2 is 6, and 2 is 1/3 of 6. Therefore, Oracle looks at this and says roughly 1/3 of 6 is CPU, 4 plus 2. So it's absolutely accurate at this point. It then comes back and does an index full scan of servers again. Now, when I look at this, my first thought is that this is probably rather inefficient. I've done 2 index full scans on the exact same index. Probably would want to think in terms of how I could keep that from happening again. But the view and the index full scan get added up, and we jump from 6 to 8. We have a cost of 1 added to the 6 here, 6 plus 1 being 7, and there is obviously some more CPU here because the cost is 8. We had 2 units of CPU here. If we bring those 2 units up here and we add the 1 more, it took us from 7 to 8, 3/8, 38%. Again, Oracle's doing a good job of figuring this piece out. And then we have an increase to 9. And again, this hash unique is CPU. So we end up with essentially 4/9, 45% of our cost is CPU. 5/9 is the disk I/O, and the 5 consists of the 3 plus the 1 plus the 1. I hope this is all clear, and if not, again, I've got the math down here at the bottom so that you can review it. There is also, as I pointed out from time to time, errors that occur when we do explain plans. And it's really important for everyone to be able to recognize when Oracle is misunderstanding what's going on. When Oracle misunderstands the plan, when the optimizer looks at the statement, it comes back to you with something that doesn't make sense. It's a good alert to you that you may have an issue with the statistics that are being stored in the database. It may be an indication to you that Oracle is just going to do the wrong thing when it runs your statement and may not choose the most efficient plan. One of the things that Jonathan Lewis has repeatedly advised in his tuning classes has been the importance of making sure that the optimizer has the most accurate information. It's more likely to make accurate decisions. So in this case, you've had a few minutes here to look at this plan. and it contains a really, really gross, egregious error. So let's go ahead and take a look at what is going on here and why we may be having some problems in terms of this particular piece of code. We start off at the bottom. Oracle says, I'm going to do an index fast full scan. Again, 999 rows, 3 8K blocks. We've seen this before. 1 unit of CPU for the sort unique. Again, all of this looks pretty much the same. So that looks good. We're going to scan this one, pull up the 141. Again, Oracle was accurate there. We've got 1 unit of disk I/O. We've got 1 unit of CPU. 50% of 2 is 1, so 1 plus 1 is 2. That works out just like 25% of 4 is the 3. But here's where we run into the problem. When we sum these up for the intersection, we get this. And this is where the problem is. We know that the 6 is accurate. We have 4 units of work here. We have 2 units of work for these sort unique no sort on PK servers. 2 plus 4 is 6. But Oracle seems to have somehow figured out that 1 unit of CPU for the sort unique and 1 unit of CPU for the sort unique no sort, well, 2 6 should be 33%. Somehow Oracle managed to come up with 84%. So it's going to see this as being a lot more CPU than it actually is. And unfortunately, that's the only way to figure out why Oracle is thinking this incorrectly is to go and run tk-prof and look at a 10053 or 10046 trace. But it's important that when things like this happen, you recognize the fact that that number is not real, and now you've got to go and try to figure out either why or come up with a plan that will, in fact, make the optimizer behave more intelligently. When we go into looking at how explain plans work with other parts of the database, whether it is specific types of objects or specific types of activities, one of the nice things about DBMSXPlan is that it does, in fact, have the intelligence to understand all of the things that we're doing and to understand the various pieces of the puzzle as Oracle alters the product. So, for example, in a case of bitmapped indexes, you'll notice here that the indexes that Oracle has chosen for my particular SQL statement here are bitmapped indexes. I not only get the fact that these are bitmapped because I named them appropriately, but Oracle lets me know that it's doing a bitmap index for a single value. It is converting it to the row ID and then accessing the table by that row ID. It also provides me with information as to how it's accessing the table. I said between 326 and 333. Oracle converted that. I can look here and make sure that Oracle converted it, and that the end result is what I wanted it to be. Had I written the statement that way in the first place, I could have saved Oracle a couple ticks of the clock. The other thing I noticed is that Oracle has applied an undocumented function called ln_NVL. And what this function does, and I've got a little note down here at the bottom just so everybody can check it, is it evaluates a condition, returns a Boolean in case something is null. Normally, a join of this type, an evaluation of this type would go, okay, is it null between 326 and 333? I don't know what to do with this. ln_NVL is, in fact, making a decision as to whether to include or not include those in terms of how it's behaving. It could be that this is not the behavior that you particularly want in your SQL statement. So by looking at this, you can tell that that is, in fact, what's going on. So again, a little more information for you as to how Oracle is viewing your particular code that you're throwing at it. Another one is parallel query. DBMSXPlan will give you the ability to look at those parallel threads and to watch how they are behaving and to make sure that if you think you have 8 degrees of parallel set on your machine, that in fact you really are getting 8 parallel threads and not no parallel threads or two parallel threads. A lot of times the decision to go parallel, people do in a hint, but they don't realize that the initialization parameters on that particular instance are set such that it will ignore the hint. So this is a way of telling what's going on there. I have another example here that I find very, very valuable in terms of understanding what's going on when using explain plan. What I did here was explain plan a very simple query. Select star from my part zip table where the state is California. Now, this particular partition table is list partition, so that every single state was in its own partition. Now, since all of California should be in one partition, Oracle should only be scanning that one partition if my query is going to be highly efficient. And I come over here and I see Oracle started with partition 1 and it ended with partition 1. So I know that my partition pruning is in fact working correctly. If I go to the next state, which is Hawaii, Hawaii was put into its own partition. I can look at this and say Oracle did a full access, but it was only on this partition. It wasn't examining full table scan on my entire table, but it was limiting itself to a single partition. Very efficient, I'm happy. But I can also say that in this case, the zip code column has nothing to do with my partitioning, and in fact there could be postal codes with a 5 in them in every single state in the United States. So therefore, Oracle does precisely what I would expect it to do, which is to scan all 3 partitions in my table because it doesn't know where those are going to be found. So this is, again, another way of getting value from these. I showed you this one before with an earlier query. One of the things I just want to emphasize again was that these columns are completely dynamic. They will show up when there is some value to show you, and of course the temp space swapping is a very, very critical piece of information to have. And we are a bit early, I'm happy to say. I didn't realize this was going to be closed mic when I set this up, so I was expecting there would be questions and provided a smaller amount of material on the assumption that there would be questions that would be interrupting us, and not interrupting in a bad way, but adding some time to this. So let's go through some of the final thoughts that I have with respect to Explain Plan. And I don't know if we'll have a chance for open mic here, but if we don't, feel free to email me. You'll find my email address on my website, and I'm sure it's pretty much available everywhere on the internet. The first thing is that Explain Plans are not going to give you all the answers. Explain Plans are going to tell you one piece of information and one piece only, and that is what the optimizer thinks it's going to do. It doesn't mean that because the cost is low, it's necessarily going to be the fastest. It doesn't even mean that the plan that it's going to actually create is the one that you'll see in the real world. So we're going to talk a little bit about how we can get there, and I'm going to show you a few other things that are extremely valuable that you can get from working with Explain Plan. And let's go through and look at these. In this case, what I did was I wrote 2 SQL statements that were essentially identical. Give me the count from the parent and the child table interjoined on the parent ID column. Oracle looked at this, went through, and said, I think the cost is $3,163, 5% of its CPU. This will take 38 seconds. I then said, okay, but now let's filter this and give them to me where the birth date is not null. And Oracle said, okay, that's going to be, in some respects, one might think a little bit harder, but on the other hand, it also is limiting the number of rows it's returning. And it says, okay, in that case, the cost is going to be marginally lower, the CPU will be essentially the same, and you're going to save an entire second by doing this. And I said, okay, that's what Explain Plan says. Let's see what reality is. So what I did was I ran both statements, and I ran them against a rather substantial data set. And you'll notice that, in fact, Oracle did get it right. This one with the birth date is not null. Here it was just marginally faster. Here it's significantly faster. You'll notice here it thought it was returning one row. Again, select count, one row, got that right. But these timings are not the same as what was anticipated here. Explain plan thought 38, 37 seconds. The reality was, in fact, 59 and 53. So you have to do both. You have to look at the explain plan to help you make good decisions, but you also have to run the real thing and find out how it's really going to perform. They don't necessarily correspond all the time. The next thing that I want to talk about is that there is a way of doing explain plans on real statements. And you can do these after the fact. You don't have to do this as part of a testing environment. I have often gone into a server hours after somebody ran a statement that was causing a problem and said, let's explain plan that statement. And they said, well, we don't want to do this. It's going to take 3 hours to run it. And I'm thinking, no, it's going to take about 30 seconds to run it, because I can go and pull the explain plan for what you already did. So I want to do this one for you right now and show you how you can explain plan statements that have already been run. So I'm going to go back into the library, and in this case, go into the DEMIS XPlan page and bring up the display cursor technique. And display cursor is extremely valuable because it does in fact allow you to go in and look at things that have already happened in the past, and as long as they're still in memory, to run them. So what I'm going to do now is something that I consider to be one of the techniques that everyone should adopt, but I hardly ever see, and that is to label SQL statements. As a DBA doing performance tuning, it's often very difficult to track down a bad statement and figure out where it came from. If you put a comment into your inserts, updates, deletes, merges, and selects, then if it identified the source of the statement, it's really easy to go, that's the statement that came from that particular source. So in this case, I've done a statement called XPlan cursor. It's going to select distinct. It's doing the inner join. Let's go ahead and run that SQL statement. It returns the results. Some period of time goes by. Somebody comes up to me and says, hey, Dan, the statement was really, really horrible. What are you going to do about it? And what I do is I go into $$SQL, or $GB if it's a rack cluster, and I get the SQL ID and the child ID where the SQL text includes that label. So I took the label for my SQL statement and I say, let's go into the SQL statements that have been run and look up that information. And from doing that, I find that Oracle has 2 different records of this being run. Not sure which one's the most current one without doing some other SQL, but for our purposes, it doesn't matter. I can say I select from table, DEMIS XPlan, but instead of saying just display, I say display cursor. Come over here and I grab the SQL ID, which is the cursor. And there's the plan for it. And I can do this to any statement that happens, and I often do this, sometimes with great regret, because this is just shooting in the dark. A row num less than, let's say, 10,000 rows. So we will try to do an explain plan on a statement of unknown derivation. Let's just arbitrarily grab one. And this time it worked because it hadn't timed out. So I can go in and take statement after statement that's been run. I can retrieve the original SQL statement, and I can look at the plan. The only thing I need to do is to have the SQL ID. So that's one of the most valuable techniques. It's a slight variation on the traditional explain plan, but it allows you to see what did actually happen as opposed to Oracle's impression of what it thinks it's going to do. And when you run display cursor, there are also abilities to alter the output intentionally. One of the things that you saw with the display was that sometimes it would pop up additional columns depending on information. When you use display cursor, you can also provide information saying, show me this, show me the I/O stats, show me the memory stats, show me the partitioning and pruning information, so that you can modify the DBMS XPlan display cursor to in fact give you some more specific information and more relevant to what it is you are specifically doing and where you're going. The other places that you can pull information about what really happened are from two of the $sign dynamic performance views. One is $sign SQL, where you can find the first 1,000 bytes of the SQL statement, or as a clause, you can find the entire statement, and they're all there. That's one place where you can pull the SQL IDs and then do display cursor. But this will also give you a lot of information about memory, about fetches, about reads and writes, about I/O wait times and cluster wait times, optimizer modes they were running in, and whether statements are bind sensitive or not. Lots of good stuff there. Then there's the $sign SQL plan view, and again, this is just an abbreviated list of columns. It's not all of them. But from here, again, you can get lots of information about your statements, get the SQL IDs, and get the operation, optimizer version information, costs, and partitioning, I/O costs, CPU costs. So again, some really easy ways to go in there and pull out the actual information after a statement has in fact really been run to figure out what Oracle did with it. I've mentioned a few times that any statement can be explained. I find that a lot of people use explain plan for select statements, but don't ever use them for their inserts, their updates, their deletes, their merges. So I wanted to throw a slide in here in particular so that it just as a sort of a visual reminder that you can in fact say explain plan for and throw anything at it, you will in fact get explain plans that will show you what's going on. And in this case, what it's showing me is one of the reasons why I detest merge statements. They're extremely inefficient in terms of how they generally work. They can also be used with any join syntax. Explain plan will work as well with the traditional Oracle join as it does with the ANSI syntax. And in 10G and 11G, I have not seen an example of it producing different plans. There were some times when the ANSI joins were less efficient in terms of how they were interpreted. I have not seen that now in a number of years. And it's also a good way to find missing joins when you are joining multiple tables to make sure that you really have joined all of your tables. What we have here is a very simple SQL statement. Again, the inner join between servers and server IDs, a cost of 8. What I did down here, just to make this a little bit more fun, was I didn't put in the where clause. I didn't actually join these two. The cost went from 8 up to 130, pretty significant. But the thing that is important is to watch for this, the word Cartesian. Now, there may be that in your particular statement a Cartesian join is appropriate, but if it is, it's something that you should be aware of as you're writing that statement to understand that you're not, in fact, joining the rows from multiple tables together. If you find the word Cartesian in a plan, you want to be thinking long and hard about whether this is, in fact, what you really did want to have happen. And the other thing that I have found very valuable in working with explain plan is it's good for busting mythology. We have, unfortunately, a lot of mythology in the Oracle world, one of which is that full table scans are bad, and that if my query is not using an index, there must be something wrong with my query. And one of the things that I will often do when I see something like this, Oracle goes, full table access, cost is 64, and I'm thinking, gee, Oracle, if you use an index, after all, I did say where person ID equals 221, why aren't you using the index on person ID and dropping that cost down? It should be much, much more efficient if you use the index. And I'll go in and I will intentionally force the index read. Oracle does exactly what I instruct it to do. It goes and reads the index, and the cost jumps to 216. And I can say, aha, Oracle was smarter than I was. It knew that reading the index plus reading the table was, in fact, going to be a lot more expensive than just doing a full table scan. So it allows me to essentially bust that myth that full table scans are bad. And it also allows me to sanity check my own feelings about whether Oracle should or should not be really using an index to do a particular statement. I'm going to close now. It is just a couple of minutes before 3 o'clock with a couple of references, resources that I have found valuable in working with Explain Plan, working with databases and tuning. The definitive source of information from Oracle is tahiti.oracle.com. That's where you'll find the documentation for all of the currently supported versions of Oracle, plus a few legacy versions. All of the demos that I've done here today are in Morgan's library, which are out on the web and you're free to access. Certainly, Tom Kite has produced a staggering amount of extremely valuable and accurate information at his website, and I can, without reservation, recommend every single one of Tom's books. They're all on my bookshelf and are all valuable resources for me. If you want to get deeper into the optimizer, deeper into understanding how it works and why it makes the decisions it makes, Jonathan Lewis is the best source on that. Both his cost-based Oracle book and also his frequently asked questions on his website. And for tuning methodology, I don't think there is anything better than Kerry Millsap's blog and Kerry's book as well. So with that, Francisco, if it's possible to open up mics for questions, I am more than happy to stay here. Otherwise, I'd like to thank everybody for the opportunity to present today, and thank you for your time.
Hello, Daniel. Thank you so much for your presentation. Like always, was excellent. Can you hear me?
I can hear you just fine.
Okay, I'm just opening the questions.
And I'm back again.
No problem. You look great.
It must be from all that sunshine I got in New Zealand.
That's very possible. Okay. I have some questions right here, and I'm still receiving some more. And basically, I have Amardeep Sidhu from India. He is asking, basically, you answered a little bit in your last slide, but he would like to ask some suggestions for further reading. Which books do you recommend?
There are a number of books that I recommend. Let me bring up my website. I have done some book reviews on it. So if you go to morganslibrary.org, click on book reviews, I have a list here of books that I recommend in particular, some of which I've written reviews on, some of which I haven't really had a chance to get to the point of saying, okay, not only have I read it, but I'm actually willing to comment on it. But I would say this list of books is probably a good place to start. If you're looking at it from a DBA standpoint, this is one of the best books out there. There's no question about that. But it is written more from a DBA standpoint than it is from a developer standpoint.
Okay. Let's go to another question. Just 1 second. I just lost it. Okay. I have Carlos Salgado. He's asking if there are no stats gathered for an object, would the CBO fall back to rule-based or do the sampling of a few records?
Oracle in any of the current versions is going to go to dynamic sampling.
Daniel,
unless
sorry.
you intentionally disable.
And he's working with 10G and 11G.
Yeah, it's going to do dynamic sampling. As long as you've got optimizer mode 2 or above, and unless you disable it by going in and changing the initialization parameter to disable it, you are going to get dynamic sampling in those situations. And if you don't, you should.
Yeah, I have another question from Israel Santos. He's asking why some queries perform badly using CBO than using RBO, even with statistics collected. He's using 10G release 1, optimizer all rows, and having migrated from 9i, and some queries perform very badly with 10G using CBO. Normally, a hint plus rule resolve the problem, but then it uses RBO instead of CBO.
Mm-hmm.
Normally, in this
Okay.
case, a merge join Cartesian appears on the displaying plane, even with joins.
Okay, I put this into one of my early slides. It said what's true in one version of the optimizer is likely to not be true in another. Good 9i code may be bad in 10G, and good 10G may not perform as expected in 11. Every version of the optimizer is different. If I wrote something in 9, the first thing I would do if I was going to move it into 10 or 11 is I would strip out every single hint that was in it, and I would run it with no hints at all, and look at what happens, and then I would start looking at whether the way that I wrote that query did in fact work really well in 9i, but it was really a bad methodology in 10 and 11, which is quite often the case. I'll give you an example of this. I'm going to show you one of the worst statements in the world, and this is sort of an interesting one. This is on my explain plan page, and I sort of ran through it earlier very quickly. This particular query with the not in and the minus, I wrote this query back at about 8.15, 8.16 of Oracle, and I wrote it intentionally because my students had a really bad data set, a small data set, not a bad one, but a small one. And I wanted them to have an example of something that would be inefficient. So I wrote something that was intentionally not the best way to solve the problem. When 9i came out, I was at the university and I had not tested this page, something I learned from that experience. And I ran this, and as I was leading the students into this, I said to the students, now this is a really, really bad query, and I ran this in 9201, and it was the fastest, most efficient query I had ever seen in my life. And I went, I don't know what happened here. I told the students, come back when you come back to class next week, I will hopefully have an answer as to what happened. And I started in 8174, and the query was a complete horrible dog. The query that was horrible in 8174 became the best query in 9201 and became horrible again in 10103 and has been horrible ever since. And it is a horrible query. There are things about the optimizer in 9i that were specifically written into 9i because Oracle thought they were a great idea, and they just said that was the worst thing we've ever thought of and removed them in 10.1. So if it's a 9i query that's been moved into 10, my instinct would be probably throw the query away and start all over again. But the first thing to do is to strip the hints out and see how it does on its own. You should not see something that runs better in the RBO than you see in the CBO. And to a great extent, Oracle has removed the RBO from the product. So even if you tell it to use the RBO, that doesn't mean it is.
Okay. Daniel, I have some more questions. I have a question for Tim Clemenson. He's asking, what GV $SQL view do you query in a rack environment?
GV $. When you are in a rack environment, you'll find that for all of your views, whether it's describe $, session, and the first column, SADDR and SID, if you describe GV $, session, the first thing column will always be in any GV $, view, the instance ID. Now, for some things like $, SQL, if you only query $, SQL, you're only going to see the SQL that's going to run on the instance to which you are actually connected. You aren't going to see any SQL running on any other instance. That may be what you want. You may only want to be looking at the instance. You might be saying, we have a problem on instance 2. I'm going to connect to instance 2. I want to look at SQL on instance 2. But it may well be that you're saying, I want to look at the performance on my entire cluster across all nodes. So you would use GV $, and then you could look at the instance ID column to determine which instance it was actually run on, or if it was run on multiple instances.
Okay, Daniel. I have one question for Ronald Vargas from Costa Rica. He's asking the impact for optimizer index cost in his playing plan. Any comment?
Yeah. There are a number of init.org parameters, index cost adjustment being one of them, which which essentially are used by the optimizer to weigh it one direction or the other, to make it appear that an index usage will or will not be more expensive than it otherwise appears. So that's going to be reflected in the plan, meaning if I say to Oracle that using an index is going to be more expensive than if I didn't have that adjustment, then it's more likely that Oracle is going to say, well, a full table scan is a better answer than doing an index scan. But if the best answer is an index scan, adjusting the cost may still make that index scan seem perfectly reasonable to Oracle. It depends on how far you adjust it. And essentially what it is a weighting. And another example of that is that when you say to Oracle in a query, I'm going to use the parallel hint, and I'm going to tell you parallelize such and such a way. It doesn't actually force Oracle to do a parallel query. What it does is it weights the optimizer to favor a parallel query. But if something still turns out to be more efficient than parallel access, Oracle will say, I took your hint into account. I weighted the parallel query as being less expensive or less of a burden than it otherwise might have been, and you're wrong, and I'm not going to do it. And that's the way hints work.
Daniel, one other question for Amardev Sidhu. Can cost be taken as the only criteria for tuning for the tuning of a SQL query? Like lower the cost will be lower, will better the plan, or we need to look at other things as well?
A lower cost is an indication of faster, but there are plenty of examples all over the internet and all over books showing that the lower cost actually takes longer. The cost is the optimizer's assumption as to what it's going to do. It may not be what it really does. So the first question, if I take a plan with a low cost and it turns out that it's very slow, the first thing I want to do is I want to look in $sign SQL plan using display cursor and say, did it actually do what explain plan told me it was going to do? Because it may be a situation where explain plan gets wrong. It said, here's what I'm going to do, but then it got into the real world and somebody had a lock on something or something was heavily utilized, and it said, well, based on the resource utilization, I'm going to go do something else entirely. Or the statistics may have changed between when you did the explain plan and when you actually ran it. So the first thing is, did it really happen that way? If it really did happen that way and it took longer, then it may well be that the plan is wrong. You might want to look and validate that the plan numbers are in fact accurate. And there are times when the plan is absolutely accurate. It does exactly what it's going to say, and it just takes longer. And that's why you have to look at what does the plan say as an indication of what to do. But in the end, you have to run the real statement, and you have to see what it really does.
Okay, Daniel, the last question I have is Ricardo Salas asking if what do you recommend? Is good to use the UTL-X PLS?
That's obsolete. It's a completely obsolete package and of absolutely no value once you get into currently supported versions of Oracle. And by the way, when I say currently supported, just for those of you who may not be aware of it, Francisco knows this as well, 10.1 and 10.2 go into de-support mode on August 1. 9i drops out of de-support mode July 31. Everything in the 10G range will be de-supported in terms of the normal patching and such as soon as you get into August 1. So if you are not in at least 11.106, which really means 11.107, you've got some potential problems there that you're going to have to deal with. But so let's take a look at this. If I look at UTLX plan.sql, you'll see that the last time this file was altered was June 6th of 2004. And Oracle said, okay, in May they added another the other XML column, and that was the end of it. Oracle stopped development on this 6 years ago. The file that you should be looking at, and one other thing here is if you look in here, you'll notice the plan table is in fact a physical table. That's no longer true. What Oracle uses now is catplan.sql. It's actually part of the data dictionary catalog. You're going to notice a difference here. This file is 4 years later. It was last modified only a little over 2 years ago. If you look at plan table, you will notice in here, if I can find it, create table, temporary table, plan table, $sign. This is in fact the plan table. One of the problems we had with the old explain plan table was the fact that it was the same table being used by multiple users. So your plan could in fact get mixed with somebody else's plan in that table, and you could be looking at results from multiple people simultaneously doing explain plan. Because the new one's a global temporary table, you don't have the ability of having multiple people using the table at the same time and possibly misreading the information that is in there. If you decide to go truncate it, you're not truncating other people's plans. If you do a delete statement, you're not deleting them. The actual plan table now, if you look and you see the word plan table, what you'll see is actually a synonym. Public synonym, drop here, and replace plan table. I'll find it. Oh, I just had it there a second ago. There's create or replace public synonym plan table for plan table $sign. So if you've been in Oracle for a long time, and it sounds like the person who asked that question has been working in Oracle for a long time and with older versions, they're used to thinking in terms of plan table being the physical table, which was a heap table. And now what they've done is they've just substituted a synonym so that people don't get confused when they try to run their old queries. Now the query just goes and redirects to plan table $sign.
All right, Daniel, and thank you so much for the presentation. Thank you so much for all your work and time. And you always did a very fantastic presentation, like you always do it. Is fantastic. Thank you for having you here. Thank you for your continued support for the Oracle user groups around the world. And I'm just going to remind the people they're going to have some more webinars coming, and just the information, the dates, and the links will be sent very soon.
Great. And thank you very much for putting this on for us.
Now, thank you so much, Daniel. I'm just going to give it a little advertising in the end. Thank you for DBIS, Database Integrated Solutions. They are the Platinum partners with NZOG and Platinum partners with LLC. Thanks to them, we are using these webinar tools and basically transmitting this for everyone. Thank you, everyone, and I hope to see you guys again in the next webinars.
Thanks a lot. Bye-bye.
Bye-bye.